All right, so 10.1 and 2, we're going to learn how to solve counting problems. So we have three different types: the fundamental counting principle, a combination, and a permutation. So what a counting problem is, the way that you would be able to identify that is a question that would say, how many ways can something happen? So how many, if you have 5 pairs of pants, you have 4 shirts, and 10 pairs of shoes, how many different outfits could you make? So those are kinds of counting problems that you would see. The fundamental counting principle is when repetitions are possible. So that's one way to identify that you have a fundamental counting principle as opposed to the other two. So if you just have 2 events that are occurring, then, so if one event can occur a certain amount of ways, like if I have 5 pairs of shoes, and then I have 10 pairs of socks, how many different combinations of those 2 could I have total? Then you would do 5 times 10. So you're just multiplying the 2 different ways that they can occur. It's pretty simple. You're just multiplying 5 times 10, or however many ways they can occur. If you have 3 or more events, then you would multiply them all together. So the way that I like to think about this is however many stages or however many options that you have are events. So we would call those events. I list those out. So if I have 10 events, then I make 10 blanks. And then in each blank I put how many times each one can occur. So if we look at number 1, I have a multiple choice test that has 10 questions. So that would be the number of events that I have. I have 10 events. And each question has 5 answer choices: A, B, C, D, and E. How many different answer keys are possible? So if I could make essentially this many forms of a test. So what I like to do is draw out 10 blanks because I have 10 questions. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each blank represents questions. So question number 1, question number 2, question number 3, question number 4, 5, 6, 7, 8, 9, 10. And they're all going to be multiplied by each other. So these are my multiplications. Can letters be repeated? So could I have an answer key that was B, 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 all the way down? No. Yes, and that would freak everyone out, right? Like I think on the test on one of the forms or something, there were a lot of B's or C's, I don't even remember, but some people were really concerned by that. But you could have an answer choice that was all A's or all B's. So that means that letters can be repeated. It's not like when I use an A, then I can only use B, C, D, and E the rest of the time. So for question number 1, how many choices do I have? 5. For question number 2, how many choices do I have? 5, 5, all the way 10 times. So 5 times 5 times 5 times 5, 10 times. What is another way that I could write this? 5 to what power? 5 to the 10th power. So you can literally write it out 10 times, or you can say that it is 5 to the 10th power. If you were to put that into your calculator, so this is when you're going to be using your calculator, you're going to get a really big number. So will somebody tell me what number you get? 9,765,625. So I could make almost 10 million answer keys with just 10 questions.
That's a bit.
No, you'll always get whole numbers. You won't get decimals. Okay, let's look at number 2. Number 2 is a little different. So it says the standard configuration for a license plate is 3 letters followed by a combination of 4 letters and numbers. So when you're doing this unit, you do have to know how many digits there are and then how many letters there are on the alphabet. So let's just talk about that first. How many digits are there if we're going 0 through 9? There are 10 digits. And how many letters in the alphabet are there? 26. Good.
Not including O.
Right, we haven't gotten to that yet. But you do need to know that there are 26 letters in the alphabet and there are 10 digits. That is something that you need to have prior knowledge of. So I hope that kindergarten has prepared you for that. So then part A, it says how many different license plates are possible if letters and numbers can be repeated. So the conditions that they give me, the first part are 3 letters. So I'm going to put 3 blanks. Those are my 3 letters. Can those letters be repeated? So I can put 26 in each blank. But it says not including the letter O, so instead of 26, I would put 25. So 25, 25, 25. I could have a license plate that says AAA. And then followed by a combination of 4 letters and numbers. So 1, 2, 3, 4. If I were to add letters and numbers together, how many total options would I have? 35, good, because I'm adding digits and letters. So 35, 35, 35, 35. So I guess I could have a license plate that said AAA, AAAA, technically. I don't think anyone has that. And so when I type that in, if you didn't want to write all of these out, I could say that it is 25 to the 3rd power times what? 35 to the 4th power. And what number do you end up getting? It's a really, really, really big number. Good, so you end up getting 23,447,265,630. That is a lot. Oh, 625. Okay. Man, I just wanted to add 5. All right, then part B. This one is a little bit different because it says that letters and numbers cannot be repeated. So I'm going to put 7 blanks still. Perfect, exactly. So I start with 25 letters. I start with 25 letters because I can have any letter except O. Then I've used a letter, so I take one away, and now I only have 24 options left. 24 letters. Then I've used another letter, so now I only have 23. That's the first 3. Then I'm going to add in the digits, so I'm going to add 10 digits, but then I'm also going to take a letter away. So the next one would be 22, but then I add those 10 digits, so it would be 32. Then I take one away, 31, take one away, 30, take one away, 29. No. So when you type that in your calculator, you also get a huge number. I got 119,099,52. Is it 000? So this one is only 11 billion. It's about half. Why is this one smaller? Because you can't repeat. Exactly. So I'm taking out all of the ones where letters are repeated. So that takes almost about half. Okay, the next one is a permutation. So that was fundamental counting principle. That's when things can be repeated. A permutation is, there are 2 ways to decide when you have a permutation. The first is that you have no repetition, and the order does matter. So some examples of that, like how to decide if order matters just based on a scenario. Anytime that you have rankings, so you have like president, vice president, secretary, or first place, second place, third place. Those numbers, those orders matter because whoever gets in first place is going to have a different ranking than someone who got second place or someone who got third place. And so anytime you have like first, second, third, or if you have offices, think about when I'm choosing these people, do they have the same job or do they have different jobs? In this case, they would have different jobs for a permutation. So this is the formula. It's called n factorial, which is like at the exclamation point, that means factorial. I'm never going to make you calculate it by hand though. We'll always use this function in the calculator, which is NPR. That's how we would pronounce it. And the P stands for permutation. The N stands for your number of options. So I'm just going to put that out here. Kind of like your sample size or however many people that you're choosing from. And then R represents how many people that you're choosing. So number that you are choosing. P just stands for permutation. So whenever we get to the back page, that'll be a C. So P stands for permutation. N is like your total number, and R is how many that you're choosing. So in number 3, how many 3-letter codes? Anytime that you see the word code, that also means that it's a permutation. So kind of think about your phone and your passcode. The order matters on that, right? Because if I type in 1, 2, 3, 4, that could get me into the phone, but if I typed in 4, 3, 2, 1, same numbers but different order, that's going to lock me out of the phone. So anytime you have a code, your order matters. How many 3-letter codes are there using A, B, C, and D if no letters can be repeated? So how many options do I have? 4. So my N equals 4. And then how many letters am I choosing within that? I'm choosing 3. Okay, so when you type those in, you should get 24. There are 24 different options. Another way you could do this is to list out all of the options, but that usually takes a lot longer, and this is an easier way to do that. Okay, the last type is a combination. You cannot have repetitions, but the order does not matter in this case. So a combination is when order doesn't matter. The best way for me to explain that is, let's say that I have 20 people in the class and I'm choosing 5 of you. And it doesn't matter, y'all are all I'm gonna have 5 of you come help me clean the board. So you all have the same job. It doesn't matter if I choose Ashley and then Bella, or if I choose Bella and then Ashley. Y'all are both doing the same thing. It doesn't matter who gets called up first. So that would be a combination. Order does not matter. So what I would write next to is that they have the same job, like they're doing the same thing at the end of the day. So the formula for this, we're not going to learn or anything like that. It's kind of complicated. We're just going to do it in the calculator. So it is NCR. So I would read this as like 5, choose 3. That's what the C kind of stands for. So if you look at number 3, it says how many committees of 3 can be selected from 4 people. So what would my N be in this problem? How many people do I have total? 4. And I'm choosing 3 of them, so my R is 3. So on your calculator, you're going to do the same thing, but in this case, you'll go to menu, probability, and I think it's option number 3. Is that right?
Yeah.
4? 3. The answer is 4. So NCR 4, 3. If you have the 84, you have to type in the 4 first. And you should get 4. So did we have the same N and R as we did in the last problem?
Yeah.
Yes, but why is this one so much less?
Because order doesn't matter.
Because the order doesn't matter. So I'm just choosing 4 of you, or I'm just choosing 3 of you out of 4. You have a lot less combinations if the order doesn't matter, because A, B, C would be the same as A, C, B. So when order doesn't matter, you have less options. Okay, so we're going to look at number 4 through 7. Now I have them all mixed up, and we're going to read the scenario and decide out of the 3 which type of counting principle it is, and then we're going to solve it. So number 4, it says how many ways can the 4 call letters of a radio station be arranged if the first letter must be a W or K and no letters can repeat. So what do we think about doing that with that? Which one of those 3 would it be?
Like the license plate one.
Like the license plate one. So that was called the fundamental counting principle. So I have 4 letters total, so I'm going to make 4 spaces. 1, 2, 3, 4. It says the first letter can only be a W or a K. So how many options do I have for this first letter? Only 2. Then what's the second condition? It says that what? No letters can repeat. So I've used a W or a K. So then how many letters do I have left? 25. Then I have 24. And then I have 23. So tell me what you get when you type that in. 27,600. Is that what everyone else got? Thank you. Okay, let's look at number 5. In how many ways can a class of 24 students elect a president, vice president, and secretary if no student can hold more than one office? So what type would that be? Permutation, because why? Order matters. They don't have the same job. So permutation, my N, how many total people do I have? And I'm choosing 3, president, vice president, secretary. So NPR 24, 3. What do you end up getting? 1,000 or 12,144? Good. Okay, number 6, it's a card problem. So we do have to have a few card facts going into this unit. How many cards are in a deck? 52. So we have 52 cards. How many different suits are there? 4, and there are how many of each? 13, because 52 divided by 4 is 13. So there's 13 of each type of suit. Then you have the numbers 2 through 10. There are 4 of each kind of card. Face cards would be king, queen, and ace, or king, queen, and jack, sorry. And then there are half red and half black. So we'll get more into that once we get to the probability unit. So for right now, all we need to know is that there are 52. Yes?
A question on the quiz going to be like deck of cards and stuff like that?
There might be some. It'll just be questions like this.
If we ask you how many,
Yeah, that would be fine.
you would answer?
Yeah, so how many 5-card hands are possible from a standard deck of 52 cards? What type would this be? Combination. Why would it be a combination? No, order does not matter. I'm just looking at the 5 cards in my hand. It doesn't matter if I take a 2 or I take a 5 first, because I have all 5 cards. So then total number is 52. I am choosing 5 of them. So NCR 52, choose 5. Yes.
So on 6, is it assuming that you can't have 2 aces or you can't have 2 kings?
This one, it doesn't matter.
Because it says no repetitions.
Like no repetitions of the exact card. So they're assuming that ace of spade is different than ace of club or something like that. So then you should get, I got 2, 5, 9, 8, 9, 6, 0. So, whoops, no, it's not right. 2,598,960. So the last part is multiple events. Like I'm choosing multiple events or different things. Like I'm not just choosing horses, I'm choosing horses and squirrels. So when finding the number of ways both an event A and B can occur, you just multiply those together. So kind of like the license plate example where we had letters and then we had numbers. It's the same thing. You're just multiplying them all together. And then that's and then when you have event A or B, you add them together. So you multiply the probabilities, or you multiply the NCR, NPR if you're saying and, like how many ways can I choose 3 horses and 5 squirrels, or how many ways can I choose 3 horses or 5 squirrels, then those two you would add. So if we look at number 8, it says William Shakespeare wrote 38 plays that can be divided into 3 genres. Of the 38 plays, 18 are comedies, 10 are histories, 10 are tragedies. So for part A, it says how many different sets of exactly 2 comedies and 1 tragedy can you read? So the first thing we need to decide is, does order matter? Like the comedies, does it matter if I choose one comedy first and another comedy second? Can they be switched? No. So this is a combination. So I'm just going to put a C out to the side. Then it says and, so that means I'm going to multiply them together. So I want to look at the 2 comedies first. What would that look like in my calculator? NCR of, how many comedies do I have total? 18, and I am choosing 2 of them. And then I'm going to multiply that by how many tragedies, or how many combinations of tragedies I have. So NCR of 10 tragedies total, and I am choosing 1 of them. And so you end up getting what? $1,530. Then part B, how many different sets of at most 3 plays can you read? So whenever you're reading plays, if it says at most 3, would that be less than or equal to 3, or would it be greater than or equal to 3? Less than or equal to 3, because it's at most 3. So I could read 0 plays. I could read 1 play. I could read 2 plays. Or I could read 3 plays. Does that kind of make sense? Because I could read no plays. And you'll end up getting 0 whenever you type it in, but you just account for it anyway. You don't have to, I guess. You could read 0, but whenever you type it in your calculator, you would get a 0 for that. So if this is an or, that means I'm going to add my combinations. So NCR, I have 38 plays total, 0, plus NCR, that should be an R, I don't know why that's a 4, of 38, I could read 1 play, I could read 2 plays, and I could read 3 plays. 0 is going to be 0, so I just did that to show you, but if you wanted to disregard that, that's fine.
So how, like, if it's on a test, how do you know whether to multiply or add?
And or. With part B, the reason why I knew it was or is because you can't read 1, 2, and 3 plays at the same time. You can either read 1 play, or you could read 2, or you could read 3. So what do you end up getting when you type that in? Did you get it, John?
9,177.
Good. Okay, for number 9, suppose there are 15 girls and 18 boys in a class. How many ways can 2 girls and 2 boys be selected for the group project? So what would I do here? Would this be an and or an or? And or? And, so I'm going to multiply. So if I multiply, this is a combination because the order does not matter. NCR, if I do girls first, I have 15 girls total. I'm choosing 2 of them. Times NCR 18 boys, 18 boys, and I am choosing 2 of them.
So could these be NPR or Big Matter?
Yes. So if it said I'm giving out 2 different awards, the first award is first, second, third place, and then for math, and then the science award I'm giving first, second, third place. So how many different ways can I give out the 3 awards for both of them?
Okay.
So that would be when order matters. So for this one, you should get 16065, 16,065.